Testing, 1, 2, 3. OK, you guys can hear me, right? Awesome. Welcome, everybody. Sorry for the small delay. You know, sometimes you're starting to build all these amazing Web3 AI things, and then the simplest thing doesn't work, like plugging in the cable, right? Not very optimistic start. Anyway, I'll try to show you something pretty cool today. A lot of stuff I want to say I cannot squeeze into these 25 minutes, but I'm super happy to chat about it later. To briefly introduce myself, I'm Branimir. I'm one of the founders and the CTO of OriginTrail. We're building something called the Decentralized Knowledge Graph. So to start this off, who in the audience, by raise of hand, has ever heard or maybe used, ideally, a knowledge graph before? Wow, OK. That's more hands than I'm used to. Awesome. So maybe I can sort of rely on you guys helping me to describe something over the course of this presentation. So what I'm going to try to do is I'm going to try and explain what the decentralized knowledge graph is in the shortest possible sense. But like I said, there's a lot of technical stuff in the back. Probably you'll get a bunch of questions floating in your head. So we'll have a short Q&A after. But also, like I'm at the conference for the 2 days, feel free to reach out to approach me, ideally over a beer. If you happen to be around the beer, bring me one. Anyways, I'm going to be telling you today about what we call trusted AI-powered semantic search, or really trusted AI, trusted knowledge infrastructure for AI. So very briefly, I'm going to introduce you with a problem. You've probably seen this guy before. His name is Geoffrey Hinton. He's dubbed as the godfather of AI. He really invented basically the LLMs, this whole new AI craze, which is actually one of the main branches of AI. There's an older branch, which is called symbolic AI, which I'll also touch upon today. And yeah, the guy was in Google, and he left Google because he got pretty scared about what his invention can do. And what it can do, I'll just show a very simple example of this poor lawyer from somewhere in the US who actually, like this is a tweet I screenshotted a few months ago, who was probably in a rush. He was doing his own work, and he used ChatGPT to prepare for some court case. And turned out that ChatGPT spit out some very, very convincing, basically, pointers to some specific law cases that never existed, never happened. And the reason why is these great new things called LLMs. You probably use, I'm sure everybody used ChatGPT in this audience. They're really great guessers. So you feed them a shit ton of data, and then over the course of time, they, in a way, let's simplify it, they become really good auto-completers. So you give some question, and then it sort of thinks, but rather just like pastes the next word in a sequence and comes up with something which is probabilistically, there's a high chance that it's correct. But sometimes, for example, for these super tricky things like law or any enterprise case, you cannot really rely on something guessing really well. It's guessing 99% or 95% or I don't know how many percent of the time well, but that little piece left is something that can kill your company, or this guy, for example, who's now actually in court himself, from what I understand, because of this problem. And what's happening here is really that it's not a new problem. In a way, it's a new manifestation of the same problem. And the problem is called the problem of misinformation. So I'm sure you guys, you've been here the last 10 years or a couple of decades, and you've heard all of these new terms we have, fake news, things like that, things about distorted or completely fake information. Well, it's been happening before AI a lot. Call it propaganda, call it whatever you want. But now we have this happening as well. So AI can amplify the problem much, much more. And I'm sure you all, since you're at this conference, you guys are surely believers in building trusted technology. And I'm sure you know about the need, because it's very hard to trust information today. Like, should you get vaccinated or not? It's a debate. Is the Earth flat? All these things. And there's a surprising amount of people that normally having a hard time to understand what is information and misinformation. So that's what Geoffrey Hinton is scared of, and that's where we see actually that is kind of the key problem of our age. That when we have an overflow of misinformation, trusted data is what becomes really the cornerstone of every system we build. And we actually believe that we're in kind of a new knowledge revolution. There's 3 knowledge revolutions that we want to point out up until now. First one happened when we had the printing press come up. So before the printing press, basically all of the knowledge was pretty much either spoken word, or churches mainly maintained them. And actually being the owner of knowledge is a very big privilege. While the church was the owner of all worldly knowledge, well, it was basically the time of the Dark Ages and everything before that. Nothing against church, but basically when Gutenberg made this thing, voila, boom, we got a renaissance. All of a sudden, like an explosion in all possible fields, art, science, whatnot. And we had a major knowledge revolution because we solved the problem of scarcity with replication. Then we had, obviously, the revolution we were living through, or kind of at the end of it, of connectivity. The internet basically brought the ability to connect fragmented knowledge. Now it's very easy to type something in Google and find like an answer to a question, which before you had to go to a library and like whatever, sift through some big library index and so on. So a lot of things changed to the better, and of course we wouldn't be here if this revolution didn't happen. We're all builders on this layer, the new layer of humanity on the internet. But then the last sort of the current revolution is really trying to solve this problem of trust. Like I said, I'm sure we all are here for the same reason. And we believe that the problem of trust, of solving trust, or really solving misinformation, is going to come from decentralized AI. So what is decentralized AI? And it's kind of a broad topic. I'll try to introduce one view on it today and how we've been approaching it for the last year almost at OriginTrail. Our pitch is actually that knowledge is a new asset class. And we believe that with this Web3 revolution, there's a lot of new types of assets being created, right? All the way from tokens to NFTs. Well, we see that knowledge is actually something that's very valuable and so far hasn't been exposed to such a market as the rest of Web3. So there's a huge potential in using knowledge to solve these problems that I've highlighted. And actually, since I asked about knowledge graphs, I'll just give a brief hint about knowledge graphs and how they, who have knowledge graphs, have been using knowledge for their benefit. Pretty much all of the big Web2 companies, Google, Netflix, Amazon, Uber, even NASA, they all use knowledge graphs in the back. And they do that because they figured out that there's a ton of value from their data. But data by itself is very raw. It's not so valuable. It's only valuable once you structure it properly, once you actually create knowledge out of it. So all of the, for example, Spotify recommending you music, that comes from Spotify's knowledge graph and a little bit of AI on top. They all say it's really a lot of AI, but knowledge graphs technically are the core. And what they do is they literally do queries on the knowledge graph. For example, give me music that people similar to me listen to. That I haven't listened to yet. Or find me, I don't know, a restaurant or something on Amazon that other people like that, I would like. It's basically a database query, but it's a database query on the knowledge graph, which is a bit more powerful database. So all of those Web2 giants build their own siloed knowledge graphs. They're growing them. They're trying to amass as much data as possible to gain as much value as possible, but they're keeping them as silos. So our mission is to do that openly, to create the biggest decentralized knowledge graph in the world of trusted knowledge, and to have anybody be able to build on it, expand and contribute to it. So I'll explain how today, and I'll show you a small demo. I'll just give you a quick hint of a couple of use cases of companies that are already using OriginTrail decentralized knowledge graph. There's on the right side, we see Swiss railway company. They collect actually a lot of knowledge from different parts of their supply chain, tracking trains, tracking parts of their supply chains, even tracking events. I've been speaking with a few people outside. They're tracking, how rail tracks, they connect. So they weld them together, and sometimes, somewhere, those break. And when that welding breaks, a train falls off tracks, and people die, a bunch of things get destroyed. Not a great thing. So what they're trying to do, actually, as Swiss Railways, is they're trying to predict when is this going to happen based on the data about welding that they have. So they track events, all kinds of things. This is actually a bunch of US retailers joined together, competitors, Walmart, Target, Home Depot, that are normally competitors, but they said we don't compete on security, so they actually exchange verifiable credential-based security audits through the decentralized knowledge graph in a private fashion. There's a bunch of food and beverage cases, even pharmaceutical cases. If you're looking to see, by the way, all of these deployments in production, so this is Web3 in enterprise world, it's not like some demo or something. You can check it out on our website. It's all been running for years, and there's many more examples like this. So what are these knowledge assets? I'll try to illustrate them on a high level, and then I'll show you a bit deeper. Basically, these knowledge assets are, if I were to explain it simply, let's say to a Web3 person, I would say these are knowledge NFTs. So you can create them. When you create them, you mint a knowledge NFT on a blockchain. And this NFT contains a reference to the actual knowledge graph, in the piece of the knowledge graph that is associated with it inside of the decentralized knowledge graph. Why do you need this NFT? Well, not only to show off that you own it, but rather when you have it, you're able to manage this knowledge graph. That means you can update it. So it's kind of like your Git repo. Like you have the rights to update new states and essentially actually add new commits. And each time you do that, a hash of that graph gets attached to that NFT. So there's not a lot of data that goes on chain. It's really your origin of information and provenance of updates, while all of the data, or rather knowledge, stays within the decentralized knowledge graph. So once you create a knowledge asset, you can actually discover it later, because now it's part of the knowledge graph. You can do all kinds of knowledge graph queries. By the way, this is all built on standardized technology, so there's been a bunch of W3C standards which have been developed over the years. So we just took that. We didn't want to invent our own. So basically, if you've ever done something with Sparkle or RDF, you can use it immediately. Or if you haven't, it's quite easy. Sparkle is like your GraphSQL, so it's quite easy to learn. And here you can see a small example of a knowledge asset. I'll show you that later. Finally, this discoverability, or search, if we may call it, also comes with verifiability. So for each thing that you discover, each knowledge asset or piece of a knowledge asset, you will know who the issuer was, basically their identity, their blockchain address, if you will, or wallet address. And you will also be able to see this whole trail, really, of information updates. And that's it. Basically, when you have that, you can build all kinds of very interesting AI systems on top. You can do all kinds of searches in the graph, and I'll show you something like that today. But just so you can visualize what's happening, and I made the simplest possible architecture here of these 3 layers. Actually, all of these layers have a bunch of things inside, but essentially visualize it like this. There's a blockchain layer, a multi-chain consensus layer, and there's this decentralized knowledge graph layer. So it's not a blockchain. It's actually kind of think of like IPFS, but knowledge graph powers. It sits off-chain. It can take in a ton of information. But then all of that information is fingerprinted and managed by on-chain resources, these knowledge asset NFTs. And that currently is connected to its own custom parachain, OriginTrail parachain. But also, even before that, different chains in the Web3 world, Ethereum, Gnosis, Polygon, and others. So essentially, this is kind of a very simplified 2-layer architecture on top of which you can build these knowledge asset applications. One cool thing about OriginTrail parachain, which we're working on right now, and also looking for ideas from the community in general, is how to incentivize knowledge creation. So how can we come up with the best possible algorithms and protocols that somebody can come and create useful knowledge for someone, and they get rewarded by tokens of the OriginTrail parachain. And the idea for this is actually that it can be done across any chain. So being a decentralized knowledge graph being a multi-chain thing, it doesn't matter if somebody, let's say, creates on Ethereum a bunch of really cool knowledge assets because, I don't know, they really like Ethereum, they would still be able to be incentivized through the OriginTrail parachain. Like I said, this is an ongoing project. So OriginTrail parachain has been alive for a year. We just established governance, opening up first channels to Moonbeam, by the way, first XCM channels. So there's a lot of things happening. And if anybody's interested in this topic, like how do we incentivize that we create useful, trusted knowledge as a community, super happy to chat with you. There's a bunch of technical use cases for this stack, including, like I said, search and discovery engines, question answering systems, knowledge marketplaces, knowledge aggregation, multi-party verification of knowledge, And actually, very often I get asked, like, okay, but how do you know if something is true or not, like when it comes inside into the knowledge graph? And the answer is that it's up to whoever is the one querying it, whoever is in this domain, this layer, knowledge asset application, to somehow utilize these primitives, knowing the origin, knowing the information trail, being able to verify certain knowledge, and then somehow connect this knowledge together and understand, aha, does this come from a trusted source? Does this match maybe with a few other sources that I own, or is it like completely off? So that's a very brief intro about like the architecture. And an example of a knowledge asset architecture here, anatomy really is, we literally have knowledge in the knowledge graph. So in this layer is where, same color, right, is where the knowledge sits in this RDF form, in the graph form. On the blockchain, we have knowledge NFTs, we have these state proofs. All of that sits on this big index, the DKG public index, really, this public knowledge graph. And it's kind of connected with this uniform asset locator, or this new form of URL. Simplest possible terms, you can create knowledge from something called JSON LD. If you haven't seen JSON LD, the LD stands for linked data. And the idea that is there that we no longer operate with key value pairs, rather we operate with something called triples, or subject, predicate, object structures. And with those, you can basically model anything in the world. So you can say, I don't know, Sub0 is in Lisbon, you know, this type of relationships. And then you can say Lisbon is the capital of Portugal, or whatever, or it's not. So long story short, you can model that, and one way to serialize it is the JSON LD format. Here you can see a small knowledge asset about the Decentralized Knowledge Graph conference, which is, by the way, happening October 9th. Check out the website, DKGCon AI, if you're interested in learning more about these topics. This will be an example of a UAL. It's actually based on W3C DIDs, or decentralized identifiers. So the idea here is that you're able to discover this NFT and then this knowledge without the need to use any sort of resolver. You don't need like a smart contract to do that resolving for you. It's self-resolvable. And then finally, this is an example of a knowledge state proof. This is a Merkle proof of the graph. So when this thing here, I don't know if you can see it, yeah, this thing here gets turned into graph. Actually, there's a serialization protocol with which you can create a Merkle proof. That means however big this graph is, you can have inclusion proofs. You can say this particular statement is part of this knowledge asset, and you can prove that on chain because you just create a Merkle proof, right? That's the same old school thing we've seen in many blockchain problem solution fits. So the idea here being that you can keep a huge amount of knowledge in one big graph and then prove it to different chains and use it in smart contracts. And when you use it in smart contracts, you can even use it in some sort of Oracle scenario. For example, you can say that if, let's say, certain institution, let's say college issued me a diploma, and if I can prove that via knowledge asset, I can basically provide an attestation like a verifiable credential attestation and execute something on chain based on that. So since I'm running out of time, I'm just going to speed it up a little bit. Basically, as I mentioned at the beginning, what's happening, what's interesting here is these knowledge graphs, they're like this old branch of AI, this branch called symbolic AI. And back in the day when it started, people sort of believed that they will be able to create this amazing artificial intelligence if only we can describe the world perfectly. So they started describing with graphs, with this basically all kind of logic primitives. There's a huge movement, maybe you've heard actually of the original Web 3.0, which was called the Semantic Web, which was envisioned by the inventor of World Wide Web, Tim Berners-Lee, Sir Tim Berners-Lee. Well, that's basically what turned into knowledge graphs. His vision didn't really come to fruition because he envisioned this open network of data everywhere. And well, we're not seeing it. And I believe we're not seeing it because all of these Web 2 giants realized how much value there is, and then they created their own knowledge graphs. So the technology is pretty much alive and well, and everybody's using it, but we don't get as much benefit from it. Centralized bodies do. So our idea is, okay, let's put that out to everybody. So it's all open source, permissionless, anybody can use it. You can pick which chain you want to build on even, so that's a big part of OriginTrail. But the cool part is you take this symbolic approach and you combine it with this new approach, with this neural approach, which can hallucinate, but yet again, it can do all kinds of interesting things. It can go completely opposite direction. So instead of super high structured data, you take unstructured data, you throw text inside, and you actually produce these vector embeddings. And when you combine these two, you can get some really amazing things. There's a lot of research papers at this intersection. If you guys are interested in that, I can also point that to you. It's not in the presentation, but I have a bunch of links I can share, which are looking at this knowledge graph plus LLM synergy. And essentially, I'll show you one today. I'll show one demo example, which we call extractive question answering. It's actually kind of like ChatGPT, but when you ask ChatGPT, what it does is it sort of invents an answer. And it invents it really well when it knows about something, but sometimes it makes a mistake. Well, here, there's no invention, there's only extraction, or rather information retrieval in that old school sense of querying something from a database, or in this case, knowledge graph. So I'll show you, this is a demo interface, and I'll show you two quick examples, just to illustrate the breadth of this. So if you heard of OriginTrail a few years ago, you probably heard about OriginTrail being used in supply chains a lot. Maybe you even centered the project around supply chains, though it's not just about supply chains, it's about really this widely applicable decentralized knowledge graph, kind of like a decentralized database you can use for anything. But I'll show you a supply chain example. And this is actually what we're building on right now. It's about to become productive very soon. Imagine you go to a store and you buy a piece of chicken meat, poultry meat. And on that poultry meat, there's a code you can scan, and there's some LOT number. LOT says, okay, this was produced on a certain date. And for that LOT number, there's a bunch of very interesting information you can access if you can access it. And imagine if I were to ask the knowledge graph. I'm going to ask it like a chatbot through this search mode. What farm does LOT 152 come from? Imagine if I had this in my hand, I could scan it, I could literally ask it. I could even ask it through sound. And what I get actually back is, these are actually triples from a graph, just formatted a little nicer. So you see the certain information such as certificate of this particular farm, what is the ID, what is the description, who's the owner, some photos, even where it is on the map. So basically a consumer somewhere in a store, without having to use or know about blockchain, they can query this and they can see this information. Now this comes from the decentralized knowledge graph, and on the side we can see the sources of this information. So these are the source knowledge assets. I'll zoom in a little bit. And these knowledge assets I can open up in something called the DKG Explorer. It's your equivalent of a blockchain explorer, but it doesn't show blockchain transactions. Rather, it shows these knowledge assets. And this is one knowledge asset here, so we can actually see how that graph looks like. And we can actually see that information that was found. So what happened here, to recap, is this question turned into a graph query using something called AI semantic search. So we use this vector representation to find the most relevant context for this question and the most relevant knowledge assets. And then we got this particular knowledge asset which we can basically dive deeper into. Not only we can explore the data, we can also we can find the NFT on chain. So this is going to open up the OriginTrail testnet block explorer. So you see that this was created 2 months ago, this NFT, who is the owner, and so on. You can also, sorry about that, that's the wrong link. You can also explore all of the resources inside of this graph. So these are these RDF resources, as I mentioned, basically the data behind it. And you can see the information provenance, or as we call it, information origin and update trail. You can see when it was created, updated, and so on, and with all of these basically being transactions on chain. So this is one example where you can ask something to the graph. You can even do that through voice. And that actually uses an NLP tool in the back. But then you can also take the same thing and you can just say, okay, I'm going to just shoot that in an LLM if I want to. So I can just change this chat mode and I can do the exact same question, and the exact same extraction is going to come out from a knowledge asset with a trusted source and verifiable origin. And if I do this and shoot just this, literally this, into In this case, it's going to shoot into ChatGPT. ChatGPT is just going to make it a little nicer, a little bit more humane. So basically, it shows the same stuff, but it says, okay, it's not a bunch of triples. It's a little bit nicer text of the same thing. So this is an example for food. But for example, we can take another one. We can take, and this is something we did last week in Berlin. So we actually created a bunch of knowledge assets about some scandalous happenings. And one of those was about TikTok. So we can ask about this. Did TikTok get fined for misusing children data? You can guess while it's thinking. Yes, no. Who says yes? We all say yes, right? Actually, we get the response because, again, this response comes from the knowledge graph, and we can see the source information. And by the way, there's a bunch of links here from The Guardian, so that it's up to you to decide if you trust Guardian or not. But you're able to find this information, and again, you're able to see all of that in knowledge assets. So if you open this graph, you're able to see it. And actually, what's cool, maybe even here it's better, you can explore the graph further. So once you click on adjacent connected knowledge assets, the graph grows bigger. Basically, you're able to explore the entirety of this knowledge graph, and this is all basically inside of the DKG. Now, since I ran out of time, I see the red blinking light. I'm just going to finish with one more slide, because I see that there's not enough info to say all that I wanted to say. So how does this look like? Basically, from some knowledge source, we create knowledge assets through the OriginTrail node or knowledge bank in this case, as we call it. And that produces embeddings. It produces these triplets that actually get published in the OriginTrail DKG, so you can make discoveries. That also mints the knowledge asset NFTs on chain. And then any dApp, which is built for discoverability, such as this example dApp, can discover this knowledge. It can determine, for example, intent using vector similarity search, can do knowledge graph queries or any vector similarity search, check integrity on chain, and then execute some transactions based on this information. Can feed it back into the chain if necessary. Having that said, if that sounds interesting, if you guys would like to build with something like this, we're actually running an initiative we call ChatDKG, pun intended, which actually you can participate with your project in. If you're building at the intersection of Web3 and AI, this might be where you want to be. We're giving out 1 million track token grants. You can scan that QR code, and basically it takes you to that website, chatdkg.ai. We have a bunch of builders already creating very interesting solutions, so you can join the community and be part of the trusted knowledge revolution for Web3. I finished with a quote from Intel late co-founder Robert Noyce, who said, "Knowledge is power, but knowledge shared is power multiplied." So come and share knowledge with us, and let's build stuff together and make the world a better place without misinformation. Thanks, everyone.
Thank you very much, sir. Unfortunately, we don't have time for questions. We run out of time. I hope you are all back at 4:20. Now we have some break, so please enjoy the break. Thank you.